Hello everyone, welcome to free crash course for competitive exams by Virat Hindustan Sangam in association with Manifest IAS Bengaluru. This program is inspired by Dr. Swamy and is convened by Ravi Shankar sir, State Education Convener for VHS Karnataka branch. So this program is held online on the YouTube channel. You can watch this online on the YouTube channel of Virat Hindustan Sangam. Also on the YouTube channel of Udaya News Karnataka. So for any further queries, mentoring, any doubts you have, for feedback, everything, you can join our Telegram channel, VHS Education Forum. So VHS Education Forum is our Telegram channel. So we're done with polity, history and economy. So now we are negotiating the world physical geography, right? How to make best use of these classes. Veterans can use this as a revision program, freshers as a program to get gist of the concepts that they are supposed to study. Okay. So we were discussing what? So we were discussing landforms and their evolution. Landforms and their evolution. What are the different landforms on the earth? How have they evolved over the time? So this was a concept which we were discussing. So we are done with what? We are done with rivers. Then we are done with groundwater. These two things we have finished, right? So what we are supposed to do now? We are supposed to do glaciers, right? Glaciers. So what is a glacier? What is a glacier? Glacier is a mass of ice. Glacier means it is a mass of ice. The definition for glacier goes like this. It is a mass of ice moving as sheets. Either the mass of ice moves as a sheet, right? Or it moves in a linear flow, just like a river, right? So either as a sheet or as a river down the slopes. It flows down the slope of the mountain. You know what is a glacier? It flows down just like a river. It flows down the slope of the mountain, right? In a trough-like valley. Where does it flow? It flows in a trough. Trough means what? It is in this shape. In this shape, it is going to flow in this valley, right? Glaciers are going to flow. So these glaciers, rivers move fast, whereas glaciers move slow, right? That is the difference. Then they move just slow means just few centimeters per day. Just small centimeters they are going to move. And what is the force? See, when it comes to the river, it is what? It is a kinetic energy. But when it comes to the glaciers, it is gravity. Glaciers move under the force of gravity, gravitational force. So in which direction does the gravity act? It acts in a downward direction. It moves in a downward direction. So which are the famous glaciers? So to know the glaciers, we should know which are. So where does Ganga originate? What are the tributaries of Ganga? Bhagirathi and Alakananda. So where does Bhagirathi originate from? It originates from Gangotri Glacier, Gaumukh, right? Whereas Alkapuri originates from, so Alaknanda originates in Alakpuri Glacier. Where does Yamuna originate from? Yamuna originates from the glacier Yamunotri or Bander Punch, right? That is where the Yamuna originates from, right? So you have, Himalayas has many glaciers, right? So if you take the Tibet region, in the Tibet region, around the region of Mansa Sarovar, you have this Satluj originating from there, Indus originating from there, Brahmaputra originating from there. There, all these glaciers are. Rivers generally originate from glaciers. But when it comes to southern rivers, Western Ghats, so is there any glacier in the Western Ghats? No. But how does the rivers originate? Because of the monsoon and underwater, groundwater coming up, right? So that is how the rivers originate in the Western Ghats, right? So here this glacier, when it moves, it carries out erosion, right? So suppose the glacier, this is, let's say this is a glacier moving, so it is a huge mass of ice, lot of weight will be there in the basement, on the soil, whatever is there, it is going to do what? It is going to drag the material. Suppose here stones are there, on the surface there are stones or anything, soil and all. So when it moves down the slope, what happens? It is going to drag those stones and everything, because of which there will be scratching. So that scratching is called as what? Abrasion. Abrasion, right? So that is how it moves down. So while moving, it is going to scratch the surface by the stones or mud that is there below it, right? So this, because of this scratching, what happens later on, if there is a big mountain, because of continuous scratching over millions of years, big mountains will get reduced to plains. Mountains will get reduced to plains because of the glacier erosion, and once it reduced to plain, whatever the glacier is there, it stops moving, because in order to move, it needs a slope. When there is no slope, when there is flat area, it stops moving, right? This is the movement of glacier. So what are the erosional landforms associated with glacier, right? So the first erosional landform is cirque, C-I-R-C-U-Q-U-E, cirque. What is cirque? I'll show you the diagram. See, this is a glacier. Is it visible? So, wait a second. Visible? Okay. So, this is a cirque, right? It is just like a valley in the river. So, valley in the mountain. This is a cirque. So, what is a cirque? This is the most common. Cirques are most commonly found in the glacial flow, in the glacier, in the mountains where glacier originates, cirques. So what is it? It is at the heads of the glacial valley. See, if there is a glacier here, at the head means this part, at the heads and at the sides, right? It is going to erode at the headward direction, and at the sides the glacier is going to erode. So when it erodes at the headward and side, it is going to create a cirque, right? Cirque. It is going to create. So when does it create? Cutting. It will cut while moving. When the glacier moves, it is going to cut this cirques, right? Okay. So when they move down the mountain, it is going to cut the cirques, right? So these are deep. See, there is depth, right? And there is width. They are wide and they are long as well. So these are the dimensions of a cirque. So they are troughs. Troughs means, I told you, it is in this shape. Troughs. So see, isn't it trough? Trough-like direction. Cirques are very, very important. So there are steep walls. If you look at the sides, they are steep walls. Means steep, narrow walls. It is not in this direction. It is in the vertical direction, right? Steep walls both at the heads as well as sides. On both these this thing, sides as well as heads, it will be narrow, right? Steep walls will be there. So whenever water gets accumulated here, what happens? See, here water is accumulated, it is called as cirque lake or tarn lake. Cirque or tarn lake. Next you have horns and serrated ridges. So horns means this. Can you see this horn? Right? See, whenever this cirque moves headwards, right, it moves backwards. So it cuts in the backward direction. Cirques move in the backward direction, and what happens? And erosion of the cirque walls will take place. When it moves in the backward direction, the wall will be there, right? Backward, it will get eroded. And when here one cirque is there, here one cirque is there. So both sides it will move in the backward direction, and when 2 or 3 cirques meet, so they will give a pointed direction, that is a horn, right? When, see, here one cirque has moved in this direction, and here one cirque has moved in the backward direction, and from that direction one more cirque has moved, it has given rise to one horn, right? This is the horn, right? So it is when 3 or more glaciers cutting headwards. When they cut headwards means backside. So when they cut headwards, you find the these cirques are going to meet and give rise to the horns, right? So they are they are what? They are high. They are very high. They are sharp. See, it is sharp, right? And they are pointed. High, sharp and pointed and steep sided. They have steep sides on all the direction. So, the best example for the horns are what? The best example is your Everest mountain. Everest mountain is a horn. Not only that, in Alps, there is one mountain called Matterhorn. So this Matterhorn, which is this mountain, means, see, when some Republic Day or Independence Day was celebrated in India, on this mountain, Matterhorn, it is a big mountain. On this mountain, they projected India's flag in the Europe. Right? You can see the Matterhorn by Googling. That is Matterhorn. It is also a arete or a what is it? Horn. Right? Next, you have this concept of arete. Arete means what? It is similar to the horn, but only two cirques are going to meet. When two cirques are going to meet in the backward direction, it is going to give to a mountain-like shape. That is a arete. Right? It has a sinuous ridge. Sinuous ridge means what? In the wave-shaped what? Tip. It has a wave-shaped tip. See? Isn't it wave-shaped? So this is a arete. Right? It is a two-sided. Right? Divide between the walls get narrower. Right? See here. Here one cirque is there. Here one cirque is there. They start eroding sidewards and they meet. When they meet, here this point will become a arete. Right? This arete is also called as serrated ridge. Serrated ridge, and it is in the zigzag direction or sinuous ridge. Zigzag direction it will be there. Right? So then you have glacial valleys and trough. What are the glacial valleys and trough? This is a glacial valley. All these cirques, water is going to come and meet, right? See, here one glacial valley is there. Here one glacial valley is there. So these are the glacial valleys. So what are these glacial valleys? They are U-shaped. First of all, they are U-shaped and they have broad floors, right? See, here from the floor will start from here. See, the floor of the trough starts from here and ends here, right? They have very broad floor. They are U-shaped, right? They also have steep sides. See, here the sides are steep, right? In the vertical direction. They also have steep sided. They are also steep sided. So here there will be, in the valleys, there will be debris. Debris. These debris are called as moraines. Debris means what? So these small stones, right? Mud, everything will get accumulated. It is called as glacial till. When the debris in the glaciers are called as glacial till. Rocks, mud and all those things. So those are called as what? Moraines, right? So here one more concept is there. Hanging valleys. So what are hanging valleys? See, can you see this valley here? Right? So this is called as a hanging valley. It is hanging above. It is not, see here one big valley is there. That is trough. Whereas there are hanging valleys as well. Right? Those are hanging valleys. They are at a elevation. They are at a height. Right? So here there is one more concept called spur. Glacial spur. See this face. This face is called as a glacial spur. This face. Face of the hanging valley is called as a what? Spur. It is in the triangular form, right? Hanging valleys are at a elevation. So they open to the main valley. See, these valleys, water will be open to the, water from here will fall into the main valley. They are open to the main valleys, right? They are triangular in shape, right? So then you have, see, when this valleys are there, right? If the valleys are at the sea level, if they are at the sea level, what happens? See, this is at the mountains. But in Norway, Sweden and Finland, in those countries, what happens? These valleys will be at the sea level, right? Glaciers will be at the sea level. This, when they are at the sea level, what happens? Sea water will get into this valley. right, from the reverse direction. Those are called fjords, F-J-O-R-D-S, fjords, very important. So in the glacier valley, if the sea water gets into, it is called as fjords or F-J-O-R-D-S, right? It is at the shoreline. Next you have, so these were the, what? Erosional landforms. So what are the depositional landforms? Deposits, right? So you have in the, see, deposits means what? There should be something to be deposited, some mud or something, unassorted. If there is an unassorted debris, debris means all the stones and all. If they are not properly arranged in sequence, that is called as glacial till, right? Glacial till. Whereas one more concept is there, that is outwash plains. So we'll discuss what is outwash plains. So here in this the glacial till, what will be there? There will be rocks, mud, sand, all these things, right? They are angular or subangular, round or sub-round shape, right, in the glacial till. So here, which will be the transporting agent? The ice will melt into water. That will be the transporting agent. Those streams will transport. So those were called as what? The water forming out of the ice is called as glaciofluvial water, or the deposits because of the ice water melting are called as glaciofluvial deposits. Ice water melts and whatever it carries with it, it is called as glaciofluvial deposits. Glaciofluvial deposits. So glaciofluvial means it is melted ice water, right? That is a term. So this will give rise to outwash plain. We will discuss what is outwash plain. But for now, you just know that in the glacial till, the material will be mixed. There won't be any separation. In the outwash plain, there will be clear separation. So there will be proper, bigger rocks will be first. So next, medium size rocks will be next. Smaller rocks will be the next, and the minute particles will be last. So it is in the reverse direction. So in the it is assorted, right? Reverse direction at outwash plains. Then you have moraines. So moraines, I told you already, they are formed out of glacial till. So what are moraines means? See, can you see small dots here? Here, dots, can you see here? So these are moraines, right? These are moraines. So they are the long ridge of deposits. Ridge means what? Ridge means it is just like a mountain, small hill. So there will be a long ridge. See, they are there from here to here. They are the long ridge of deposits. So there are multiple types of moraine. Here you have, see, at the end, at the end of the glacier, if there are certain moraines, those are called as terminal moraines. These are terminal moraines at the end of the glacier valley. Then you have if they are at the side, see, here they are at the side of the valley, on both the sides. If the valley is there like this, if the moraines are here and here, it is called as lateral moraine, right? Lateral moraine and terminal moraine. Then see, if the lateral moraine mates with the terminal, see here there are lateral moraines. This is a lateral moraine and this is a lateral moraine. If this meets with the terminal moraine here, it will form a horseshoe shape, right? So next you have, then one more thing is they are called ground moraine. Ground moraine, see, if the moraines are on both the sides, they are called lateral moraines. If they are spread across the ground, they are called ground moraine. So the definition for ground moraine is irregular sheet of till over valley floor. On the valley floor, if they are not sorted, they are ground moraines, right? If it is at the center, here, it is central moraine, right? Central moraine or medial moraine. Then you have the concept of eskers. So what is a esker? So I'll show you the diagram. See, this is a esker. Visible? This is a esker. So what is a esker? So when the ice melts in the summer, right? when see, let's say there is a ice block like this. Ice here melts. So there will be pores, right? So within the pores, it will come to the bottom. From the pores, it is going to come to the bottom. Water will start seeping from top to bottom and start flow beneath the ice. Below the ice, the water will start to flow, right? So what happens? And when they are flowing, when this water is flowing like this, the border, what will be the border of this ice flow, ice water flow? Ices will form the border. So there will be a river of ice water. Both the sides, what will be the border? The border will be ice. Ice will form the border, right? On both the sides there will be ices. So what is this? What is this esker, right? So when the water melts in the summer, when it starts flowing like a river below the ice cap or below the ice. So what happens? There will be some material, coarse material like stone, cobbles, pebbles, mud, all those things, right? They will settle. So they cannot flow forever. They will settle, right? They will get settled in between, right? And they get settled in the valley. In this valley, they will get settled. Suppose this is a valley, they will get settled. So when the whole ice block melts, what happens? Then only you can see the esker, right? Then only you can see the esker. See, this is a esker. So water would have flown like this, and while flowing, there will be some coarse material which would have got deposited like this. So when the ice water melts, this can be seen. If ice water doesn't melt, this cannot be seen, right? That is the concept of esker, right? Then you have outwash plain. What is a outwash plain? See, when I'll show you the diagram. Here is the outwash plain. See, from here all the water comes. From here all the water comes, and it is going to after forming everything. So where is the water coming from? Okay, let us say it is coming from this direction. So at the end of the glacier, whatever is remaining, whatever the debris that are remaining, they are going to constitute a outwash plain. So it is at the foot of the glacier mountain. If there is a glacier mountain, see, this is a glacier mountain. At the foot of it, this is a plain. There is outwash plain, right? Outwash. It is at the foot of the mountain. Glaciofluvial deposits will get deposited here, right? Glaciofluvial deposits, I have told what it is already, right? They will get deposited there. So yesterday I told you alluvial fan. So alluvial fan, when the river meets the plain area, alluvial fan will be formed. Similarly, when from the valleys, when the river meets the plain, you will see the outwash plain. But in this outwash plain, there will be sorting. Bigger materials can be found first, smaller materials can be found last, right? Because when the water flows, bigger material gets dropped first when they hit the plain. Smaller material can travel little further and they get dropped last, right? This is the concept of outwash plain. Then you have drumlins. What is a drumlin? This is a drumlin. Can you see here? So it is smooth and oval shaped ridge. It is in the oval shape, right? It is a oval shaped ridge, and it is consisting of till, gravel and sand. It is made up of till, gravel and sand. Three materials. So this will be formed. See, if the ice is moving in this direction, drumlins will always form in the direction of the ice. So if this is a drumlin, this is like this, so it will always form in the direction of the ice. In which direction ice moves, drumlins we are going to form in that particular direction only, right? It shows the movement of glacier. In which direction the glacier has moved, the drumlins are going to show, right? So they are parallel to the direction of ice. See, there are two concepts here. See, this end, this is bit fatter, right? This end is bit fatter. So that is fatter end is called stoss. It is a fatter end is called, this end is called stoss. So what is a stoss? So it is blunter and steeper, means it is somewhat bigger and steeper. There will be height. Here there is some height in this. Here see, there is no height. So on the other hand, you have tail. This is a stoss, this is a tail. This will be blunter and it will be steeper, right? So what happens? Why does this drumlins are formed? Because of the dumping of the rock debris. See, when the ice moves in this direction, what happens? It is going to push the stoss end. So when they push the stoss end, it is going to grow bigger. Here, let's say here will be the stoss or a drumlin. Ice is going to come and push this, right? When it pushes, this will grow like this. So a stoss will be in this direction, in this shape, right? So here it will be steeper. This is the concept of a drumlin, right? It is because of a dumping of the rock debris. Rock debris will get dumped to form a drumlin. Next, this is the whole concept about glaciers. So this finishes your glacier concept, right? Next, we will move towards waves and currents. Waves and currents. Waves and currents. So what is the difference between a wave and a current? So waves, currents are movement of water, right? So waves you can just find at the shoreline, right? At the beach side you can find the waves. Whereas currents are just big, it is as simple as this. You have these rivers, right? So if there is a river within the ocean, or if there is a river within the sea, that is called as a current. There is a current of water moving throughout the oceans. That is a current. Waves, you know. So waves, there will be, it will be in the form of this direction. Actually, they will come and hit the shore, right? So waves, actually waves also there will be this shape actually, right? So here there will be churning of material. So waves also move like this, and when they hit the shore, they will take this shape. So actually when they are moving in the big ocean, they will be in this direction, right? When they hit the shore, they will come and crash, right? So that is waves. So coastal landforms. So we are talking about coastal landforms. So how the landforms at the coasts are formed, right? We spoke about how landforms are formed in the mountains. Now we are talking about coastal land. So in the coastal land, there will be a wave break. Waves are going to come and break at the beaches. That is when the coastal landforms are formed, right? So when the waves are going to come and break at the shoreline, what happens? There will be churning of material. So whatever the materials will be there, they will get disturbed, they will get rolling, right? That will be there. Then you have, that is the first factor of influencing the coastal landform. The second factor is land and sea floor configuration. So what is the configuration of land here? Is there a mountain here? Or how is the sea floor? Is the sea floor deeper or is it shallower? That will also shape the coastal landform. The third factor is advancing and advancing or retreating coast. Advancing coast means what? See, retreating coast means the coast is going backwards. Advancing means it is moving towards the land, right? Coast is moving towards the land. All these three things are going to affect the coastline, coastal landform. So you have two types of coast. Two types of coast. The first coast is high rocky coast. High rocky coast. So you take high rocky coast. So you take the example of, see, here there will be one cliff. This is a mountain, and here there will be sea, right? Suddenly mountain, and at the bottom there will be sea. This is a example of a high rocky coast. So this will be found on the Western Ghats. Suddenly Western Ghats are there. This is a mountain, and here there is Arabian Sea. So this is a high rocky coast. These are submerged coast. Submerged coast means what? See, here the land is submerged. Land is submerged. Whereas there are other type of coast, emergent coast. So if you see the Chennai side, Bay of Bengal side, there is no mountain, right? They are called sedimentary coast. So when there is a sedimentary coast, they are emerging. The coastline is emerging. You can see the sea floor. Here you cannot see it, right? It is submerged, right? Submerged coast. So here there will be high indentation. High indentation means the coast will be not be plain. There will be, the coastline will be like this. There will be lot of disturbances. So high indentation in the high rocky coast. So here what happens, if there is a river coming or if there is a river flowing into the sea, what happens? The river will get submerged. It is going to drown into the sea directly. There won't be any delta formation in the high rocky coast. The river is going to just flow into the sea, right? River will drown into the sea. So this is, you can, another best example is your forts. I told you, forts, that is glacial mountains. Glacial mountains, if they are at the sea level, the sea water will go into the valley. So that is also example of a high rocky coast. Here will be the glacial valley, glacial mountain. Here there is a valley. From this valley, here there is sea. The sea water will go into this valley, right? This is also example of high rocky coast. So there is a sharp drop of hill. Hill will sharply drop at the high rocky coast. So here erosion dominates. So erosion means the water will come and erode the mountain. So erosion will dominate here. So it is actually what? The force of water, the force of the waves against the land. So the waves are going to come and hit the mountain. So when it hits the mountain, what happens? There will be cliff will be formed. So it will hit the cliff. The force of the wave will come and hit the cliff. When it hit the cliffs, there will be what? There will be wave cut platform. So what is a wave cut platform? See, here let's say there is this mountain, steep mountain, here there is sea. So the waves are going to come and hit it. So when they hit, what happens? It is going to undergo erosion and there will be some platform like this, right? This is called as a wave cut platform because it is eroded by the sea. There will be wave cut platform, right? So these fragments, so whatever the, when it comes and hits the cliff, when the wave comes and hits the cliff, there will be, it will be broken into small fragments. So these fragments will be in the round shape and they get deposited on the offshore. Offshore means, what is offshore and onshore? So off the shore, right? That is away from the shore, away from the seashore. What happens? These fragments will go and get deposited and there will be wave built terrace. So when the fragments, if these fragments which are broken from the wave, so they will be going and deposited on the seashore, right? So because of this deposition, there will be, what happens? If there is a, this is a seashore, there will be some platform like this. So this platform is called as wave built terrace. So this is wave cut terrace, this is wave built terrace. So whatever the fragments, they are going to get accumulated on the shore and there will be a wave built terrace. So this is the concept, say, right? So when these fragments will give a material to the long shore currents. So I told you currents are rivers within the ocean. So for these rivers within the ocean, what happens? It is going to carry, the currents are going to carry these fragments and when they carry, they are going to get it deposited at the seashore on the beach side, right? So these materials are going to be carried by the long shore currents. Long shore means when the shoreline is very long, the current will carry the material and get it deposited as what? Beaches. They get it deposited as beaches, beach sand, or they might get it deposited as bars. So what is a bar? So if this is the coastline, beach, right? So here there will be full of water, this is land. So the current are going to get the fragments and get it deposited here, right, in the form of a bar. Bar means a ridge, small hump-like structure, right? If this is the water, a bar will be like this. It is visible above the water, right? So there will be a bar deposition because of the sediments, right? And if it is acting as a barrier to the waves, so waves are coming and hitting the land, means if this bar acts as a barrier, it is called as barrier bar, right? So when this barrier bar gets jointed, see, if this gets jointed to a land, it is called as spit. When the barrier bar gets joined to the land, it is called as a spit, right? So then when this spit, what will happen? It is going to block this side also. On the other side also, it is going to get joined later on over thousands of years, millions of years, right? When it joins on the other side also, the bay will be blocked. What is a bay? Bay is three sides land and one side water, opposite of peninsula. So here the bay will be blocked. This is a bay. See, if there is land, so the bay will be blocked. Here also there is land. Here also there is land. So there will be water just here. It will get blocked. So there will be only, see, in the spit what happens? So spit, one side is joined. So here you have land, here you have land, here you have land, right? There is only one way for the water to get in. This is a bay. Later this bay will also get covered. And when it gets covered, there will be a lagoon formed. Lagoon. Lagoon is, it is just like a lake, right? So rivers will come and flow into the lagoons, right? It is covered from all the sides. It will be a lake within the sea, right? Lagoons will be formed. Later on, the sediments from the rivers and the waves are going to get deposited here, and it will form a coastal plain. Lagoon will get changed into a coastal plain because of the deposition. Clear? Okay. Next you have, that is the high rocky coast. Next you have the concept of low sedimentary coast. Low sedimentary coast. What is a low sedimentary coast? So here, see, in the high rocky coast, rivers are going to drown into the sea. They are not visible. Whereas in the low sedimentary coast, the best example is east coast of India, Chennai, Puducherry, all these things, right? So the river will flow into the sea, get extended into the sea. There will be delta formation. Delta, I told you what it is. So it is a alluvial fan at the sea river interface. So there will be delta formation. See, in this low sedimentary coast, there will be marshes and swamps. What are marshes and swamps? So it is just like presence of water will be there. So it is like mix of vegetation and water. When there is mix of vegetation, the best example is you have your mangrove swamps. ಹಳ್ಳಿ ಕಡೆ ಗಿಡಗಳು ಮತ್ತೆ ನೀರು ಮಿಕ್ಸ್ ಆಗಿರಲ್ಲ ಪೊದೆಯಲ್ಲಿ, that is swamp, right? Swamp and marsh, right? So here in the low sedimentary coast there will be deposition. In the high rocky coast there will be erosion because of waves. In the low sedimentary coast it will be deposition. Deposition by what? Deposition by both the rivers, deposition by rivers and waves, both will deposit, right? Okay, so there will be here also, because of the sediments there will be bars. So there will be bars, there will be barrier bars, there will be spits and lagoons as well as coastal plains. Similar phenomena in the high rocky coast is witnessed here also, the low sedimentary coast. So western coast of India is the high rocky coast, eastern coast is the low sedimentary coast. So what are the erosional landforms? So you have, because of waves, what are the erosional landforms? You have cliffs, terraces, caves and stacks. These are the four erosional landforms. What are these? We will see. Cliff is if there is a mountain and it suddenly falls into the sea, it is a cliff, right? So they are steep, right? And at the foot there will be a gentle platform. So if this is sea, I'll show you again. So if this is a cliff, this is sea, there will be a gentle platform here. That platform is what? It is a wave cut platform. Wave will be wave would have cutted it, right? Wave would have made this. So here there will be rock debris. Because of the erosion, there will be rock debris. Rocks will be there, right? So waves will, what happens? Waves will create some hollows. Hollows means wave is going to remove the rock. When the wave is going to erode the rock, it is called as hollows. So if waves are going to create a hollow, it is called as hollows, right? So later on, when this hollow gets bigger, what happens? When this hollow gets bigger, here a cave will be formed, right? Because of the waves, a cave will be formed. Later on, what happens? This roof is there, right? This roof will get collapsed. So here there will be a cave. This roof will get collapsed. So when the roof get collapsed, cliffs will be roof will get collapsed. So the cliff will move backward because of the waves, right? So when in this roof collapse or the cliff and the caves, what happens? There will be some small remnants. Some rocks will be left out, rock outcrops, just like monadnocks in the rivers, right? River erosion. So those are called as sea stacks. Sea stacks. Later, this sea stack will also be eroded. So the caves will be there. Caves, after cave collapses, the cliff moves backward, and the cliff move backwards. There will be some rock remnants. Those are called sea stacks. Those sea stacks will also get eroded, and there will be what? There will be coastal plain, absolute coastal plain, or beach will be there. Proper beach will be there. So I'll show you, if possible, what is a see, this is a cave. Can you see this? The waves would have cut the cave. This is a cave, right? This is a proper cave. Then you have this is also a cave. So all these are the images of cave. See here. This is a cave. And this is a sea stack. See? Something remaining. Later on, this sea stack will also get eroded. When it get eroded, there will be proper coastal plain. Understood? This is a cave. This is a sea. If there, I'll show you the cliff also. What is a cliff? See, this is a cliff. See? Suddenly, it is dropping. Suddenly, it is dropping, right? I'm not able to write here. Suddenly, it is dropping. See, here is a cave. Here is a... Where did this go? Here there is a sea stack, right? This is the concept. Okay. So, sea stacks will also get eroded. There will be proper beaches, coastal plains will be formed. Then you have depositional landforms. Depositional landforms. What are the depositional landforms? Beaches and dunes. You would have seen the beaches. Behind the sea beaches, there will be lot of sand. So that sand will be properly accumulated there. That is dunes, right? Dunes. So dunes are actually sand dunes. I'll show you sand dunes also. See, this is a sand dune. Actually, this is a proper sand dune, right? This is a proper sand dune. See, here, this is a beach, and here you have sand dunes. Clear? Visible? Okay. Okay. So this is because of deposition. These beaches and dunes are formed because of deposition. Where do the sediments come from? The sediments come from the land, rivers, right? So these are temporary features. Beaches, they are not permanent. They will get eroded. So these are temporary beaches. There are sand beaches. Sand beaches means there will be sand. Shingle beaches. Shingle beaches means what? There will be small pebbles and cobbles. Means you know the pebbles, right? Some beaches will have lot of pebbles. So those are shingle beaches or pebble beaches. So behind the beach, just as I showed in the diagram, behind the beach there will be sand dunes. Sand dunes will be there behind the beaches. So in that sand dunes, I showed you the dunes. So there sand will be stratified. Stratified means they will be properly arranged, right? Bigger ones first, smaller ones last. So these sand dunes are long ridges along sedimentary coast. So Chennai coast, just behind the sea, just behind the beach, you have sand dunes. So they are long ridges. They will be all along the coast. Full coast they will cover, right? They are long ridges. Then you have the concept of bars, barriers and spits. So I'll show you the barrier also. Barrier bar. Because without seeing images, geography is impossible to understand. Barrier bar. Where is a barrier bar? See, you can call this as a barrier bar, right? This part is a barrier bar. So I'll show you the spit also. Barrier bar and spit. See, this is the barrier bar. This is a C, this is a barrier bar, right? So this bar getting key to one position is a spit. Clear? This is a spit, this is a barrier bar. Clear? This is a bay. In the bay, see, there is all side land, one side water. What is a lagoon? If this also get closed, it is a lagoon. This inlet also get closed, it is a lagoon. Clear? Okay. So since barrier bar is a ridge of sand in the sea. It is a ridge of sand. It is made up of sand in the sea. It is offshore, around the shore, and it is parallel to the sea. It is parallel to the sea. So this offshore bar, see, this bar gets mixed with the sand. If it gets mixed with the sand, it is going to. If this bar gets mixed with the sand, it will become a barrier bar, right? So this is actually across a mouth of river or bay. See this barrier bar here, there will be river flowing like this. So across the river there will be barrier bars, right? Because river will carry lot of sediments and they are going to deposit there. Across the river there will be barrier bar, right? So across the mouth of river or bay you will have the barrier bar. Then you have, if it gets keyed up to one location, it is called a spit, right? So if this bars, barriers and spits, so because of this is a single small thing is a bar, bigger one is a barrier bar. This bars, barrier bar as well as spits, if all these things come together, what happens? There will be a small opening to the bay, right? See here, spit is there, barrier bar is there. There will be small opening to the bay, right? This bay will later get converted into a lagoon, and the lagoon into a coastal plain. This will become a, here this will also close, and this will be filled with sand, and it will become a coastal plain. So this what are the benefits of this, the benefits is, you have, see, if the tsunami or something comes, this is going to prevent it from falling on the land, right? Tsunami, cyclones, everything, it is going to stop, right? That is one benefit. Then it is going to maintain the sediment budget. It is going to maintain sediment budget. Sediment budget means what? What is the sediment? So how much sediment is getting deposited? How much sediment is getting eroded into the sea? That is, if there is a barrier bar, the sediment is not go into the sea. It will stay here, right? It will stay within the, where is the barrier bar? If the sediments will be blocked by this barrier bar and it will stay. So this is going to maintain the sedimentary budget, right? So then we will focus on the next concept, winds. Winds. So this is the barrier bar. This is a spit, right? Spit getting connected. Next, we will focus on winds, right? So winds, you have winds actually, they are there everywhere, right? So in the hot desert, the erosion and deposition of wind is very, very important. Hot desert, in the deserts, the erosional factor as well as depositional factor of wind is very, very important. See, when the wind moves over a desert, what happens? It gets heated up quickly. Because the sand would have been heated, the wind will also get heated up quickly, right? When the air above the sand gets heated up, what will it move? What will it do? It moves upward, right? Because it becomes lighter. When it is lighter, it is going to move upward, right? So when it is going upward, what happens? There will be turbulence. When the air after getting heated at the surface of the desert, when it moves upward, there will be turbulence. Turbulence means what? So it will be rotating, right? Turbulence. So there will be lot of disturbances in the upper atmosphere. That is turbulence. So turbulence, you have eddies, whirlwinds, all these are turbulences, right? When the upward movement of air gets obstructed, there will be turbulence, right? Okay. So winds, what is the wind going to do? Wind is going to cause deflation and abrasion. Deflation means, suppose there is a rock in the desert, it is going to deflate it. Deflate it means it is going to cut the rock into small pieces, right? How does it cut? So at the surface of the rock, the wind is going to cut the surface of the rock. How does it cut? It is going to take the sand and put the sand on the rock. So the sand will be having frictional forces. When it moves over the rock, it will cause friction, because of which the rock will get eroded. So there will be abrasion, right? When the sand is blown against the surface, so there will be abrasion and the rock will get eroded, right? Because of the sand and silt. Then you have, see, in the deserts, actually it is not only the wind. We will be surprised, there will be rain will also be a factor in the deserts. Sometimes there will be lot of rain, right? So that when rain happens in the desert, there will be flood called sheet floods, right? The water is going to move like a sheet on the sand. That is a sheet flood. So when the rain happens in the desert, it will be called sheet flood. It will be a torrential rain. Means there will be too much rain in the desert. So because of this sheet flood, what happens? There will be mass erosion, right? So see, first what happens? There will be rock. This rock will be eroded by what? By wind, right? And it is getting converted into sand. Rock will get converted into sand. Why does the weathering? So this is called as weathering. So why does weathering happen there? Because there is temperature change. One is the movement of the sand. Second is the rock is going to break open because of temperatural change. So because of these things, rocks are going to get converted into sand. Who will move this sand from one position to other? It is either the wind or the sheet floods. Sheet floods or the wind are going to move, right? So the rain will move the sand from one position to other, right? Okay. So this is called as mass erosion. When the eroded, degraded or the weathered rock, if it is moved from one position to other position because of wind or the sheet erosion, it is called as mass erosion, right? So what are the erosional landforms? So what are the erosional landforms in the desert? So first you have pediments and pediplains. Pediments and pediplains. So what are pediments? So you have gently inclined rocky floors. So it is just like a cliff in the in the deserts also there will be mountains like this. So they are gently inclined. Actually this is steeply inclined. So there will be gently inclined like this mountains, right? So those mountains, gently inclined rocky floors close to the mountains are called as pediments. So there will be mountain like this, and when it is going down, it will gently incline like this. This position here there will be sand. This position is called as pediments. This is at the bottom of the rocky floor or the bottom of the mountain. Bottom of the mountain. What will be there? Pediments will be there. So how does this pediment will be formed? It is formed because of erosion. These pediments are formed because of erosion. Formed because of erosion. Pediments, right? So because of what erosion? Sheet flooding. It is formed out of sheet flooding. I told you what is sheet flooding, right? So here there will be, if there is a steep margin, see, I'll show you the diagram of pediment. That is better. Very big picture. See, this is a mountain. So this is a mountain. Here what you are seeing at the bottom, these are the pediments. These are the pediments, right? So these pediments, what happens? If there is a steep margin, erosion will start because there will be steep margin, right? It will be in this form. Here this will be gentle, whereas this part will be gentle. Here this will be steep, because of which there will be erosion. Erosion. What erosion? The sheet erosion will start. So this steep wash slope plus cliff retreat backwards. What happens? This one, this part and this steep wash slope, both of which because of erosion, it will move backwards, right? Because of the what? Because of erosion, this part will get eroded, this part will get eroded, and this mountain is going to move backwards, right? So this is called as what? Back wasting. When the mountain or the pediment moves backward, it is called as, because of erosion, it is called as back wasting or parallel retreat. Also called as parallel retreat. When just like sea stacks, when this mountain gets reduced to a single stack like this, that stack is called as Inselberg. Single stack is called as Inselberg, just like a sea stack, right? So later on this stack will also get eroded and there will be featureless plain. When the stack will also get eroded, so what happens when the sea stack eroded? There will be coastal plain. When the Inselberg gets eroded, whatever the plain that is formed is called as pediplain. Pediplain. Then you have the concept of playas. What are playas? So I better show the diagrams for everything. What are playas? Uh-huh. Playas in desert. So, not able to find the exact diagram. So see, here there are mountains on, if the entire thing is surrounded by mountains in the desert. This is a desert. What happens? See, around the mountain there will be, around this plain there will be mountains. So what happens? There will be hills around the plain area, and from the hills water will flow. Water will flow to this plain area. It is going to flow to the plain area, that is everywhere around there is mountains, and water is going to flow to the center. At the center there will be deposition of sediments. Sediments get deposited, right? So there will be a level plain there, the sediments get deposited there, and when water gets there, when water gets here, there will be what? There will be, when the water gets there, there will be shallow water body called as playas. If water gets accumulated here, that is a shallow water body called playas will be there. Playas will get formed. So these playas, in these playas, there will be very less water. When this water gets evaporated, what happens? Salts will be left behind. When the salts are left behind, it is called as alkali flats. Alkali flats, right? This is the concept of playas. Then you have deflation hollows and caves. So what is a deflation hollow and cave? See, when there is a weathered mantle, when weathering happens, when the weathering of rocks happen in the deserts, what happens? So they will be blown away by the wind. When they are blown away by the wind, that place there will be depression. When there is, here there will be one rock, right? This will be weathered, and when it is weathered, the wind will blow away the weathered material. Here one depression will be formed, right? Like this. So there will be a depression. This is depression is called as deflation hollow. It is called as deflation hollow. So it is because of what? Because of abrasion of sand. Sand will abrade this surface, scratch this surface and make it into depression hollow, right? On the rock surface, sand will scratch and there will be depression hollow also, and it will be blown away by the sand. When it is blown away, it is called as blowouts. When the depression is blown away, it is called as blowouts. So when this blowouts become deeper, when this blown away rock becomes deeper, it will form a cave. The next, after the blowouts, there will be a deeper form of blowout is a caves. Caves will be formed in the desert. Next you have mushroom, table and pedestal rock. Mushroom rock, table rock, pedestal rock. So I'll show you what is a mushroom rock. Mushroom rock will be easily available. This is a mushroom rock. This is a mushroom rock. So mushroom rock, mushroom, table and pedestal. These are rock outcrops. Means rock is outcrop. There is a rock which has outcrop, right, from the land, from the surface. So this is a remnant of resistant rock. What happens earlier, here also rock will be there. This will, because of abrasion, sand getting blasted against it, this rock will be eroded. When the erosion happens, this will form into this shape. Because why this didn't get eroded? Because this is hard rock. It is a hard rock, so it won't get eroded. So this gets, see, this is a polished form, because the sand will, you know, right, sandpaper is used for polishing. So this is a polished form. When it is polished form, there will be a mushroom rock, and this is called as a cap of the mushroom rock. Cap of the mushroom rock. So also this is called, see, this is just like a table, right? This is just like a table. This part is cap. This part is above part is called as tabletop. Tabletop. So when this gets fallen away, when this cap gets fallen away, only this part will be remaining. That is called as pedestal. So this part is called as pedestal. This is cap. This is tabletop. Clear? Okay. So then you have erosional landforms is done. Depositional landform. Depositional landform. See, this wind is a sorting agent. Sorting agent means what? Just like a river. So there is there will be coarse materials in the river. So rivers are carrying sand and everything, sand, rocks. So the bigger rocks will drop first. So when the river moves from hills to the plain area, the bigger rocks will get dropped first and smaller things will be carried further, right? So just like the water, wind is also a sorting agent. Wind will also sort the material. So because of the velocity of the wind, if the velocity of the wind is higher, the sand, the grains of the sand will move faster. If velocity is lower, the grains will move slower. So the wind will sort the materials. So bigger grains first, smaller grains last. There will be proper separation, right? So when the wind slows, so when wind is in movement, sand will also be in movement. When the wind slows, the grains of the sand will get settled. The grains will get settled. So there is this concept of sand dunes. Sand dunes. So what are sand dunes? So these are the sand dunes. So you will see this in the, you will see it in the deserts, right? So these are sand dunes. These are sand dunes, right? So you will see it in the desert. So to form these sand dunes, there should be what? There should be obstruction. There should be some obstruction. There should be a tree here or something. There should be some rock or something for the sand dunes to be formed. So there are many types of sand dunes. So this is a sand dune. So the first form of sand dune is Barchan, not Bachchan. Barchan is the sand dune. So it is crescent shaped. Crescent shape, you know, right? Crescent means, so this shape is called crescent shape. So Barchan is a crescent shape. It is pointing away from the wind. See, wind is moving in this direction and this is pointing in this direction, right? This is pointing this side, wind is moving this side. Barchans are pointing away from the wind. Then you have parabolic dunes. So these are parabolic dunes. So when does the parabolic dunes are formed? If there is vegetation, if there is some grass or some tree, so then parabolic dunes are formed. So what is the difference of parabolic dunes? So here they are reversed Barchans. See, Barchan, if you reverse it, it is a parabolic dune. See, the direction of the dune and the direction of the wind are both the same. So that is the difference. Then you have a sieve. What is a sieve? This is a sieve. Sieve, it is a Barchan, but one leg is cut off. So it is a half Barchan. So why does the leg is cut off? Because wind gets shifted in direction. That is why one leg gets cut off. Then you have longitudinal dune. This is a longitudinal dune, right? See, it is in the long, there is a very long dune. This is a longitudinal dune. When does a longitudinal dune is formed? When the sand supply is poor. When the sand which is being supplied, it is poor, means then longitudinal dune is formed. So there should be a wind should be constant and the wind should be constant and sand supply should be less in the longitudinal dune to be formed. This is a long ridge, right? See, you can see the long ridge, right? Ridge means it is above the ground, right? So then you have transverse dune. This is a transfer dune. This is perpendicular to the wind movement. See, wind is moving here. Transverse dune is like this. So this is because of the constant direction. So wind is moving in the constant direction. That is why transverse dune are form. This is perpendicular, right? And also wind direction. When the wind direction is constant, transverse dunes are formed. So this ends the chapter on landforms. Landforms chapter is ended here. Then you have the concept of structure. Then you have the chapter on composition and structure of atmosphere. Composition and structure of atmosphere. Right? How is the atmosphere formed? So atmosphere is a mix of gases, right? There are multiple gases. This envelops the earth. Envelops the earth like a cloth, right? Just like how we wear cloth, earth will wear the atmosphere as its cloth, right? So 99% of the atmosphere ends within 32 kilometers. 99% of the atmosphere is within the 32 kilometers. So what is the composition of atmosphere? Atmosphere consists of gases. It consists of water vapors. It consists of dust particles. What is water vapor? You know, water getting evaporated, right? So water vapor, gases and dust particles are there. In the lower atmosphere. In the lower atmosphere, the most prominent gas is nitrogen. 78% of the atmosphere is nitrogen. Oxygen is 21%. Argon is 0.9%. Carbon dioxide is 0.036%. Then you have argon, krypton, xenon, all these gases, right? All these gases are there. Then at the higher atmosphere, whatever I told is with respect to lower atmosphere. Higher atmosphere, there won't be oxygen, there won't be carbon dioxide, water vapor is also not present in the upper atmosphere. So first we will talk about the gases. So what are the gases? The first is carbon dioxide. So this carbon dioxide, it is transparent to insolation. Means what? The sun rays comes from the sun. So this carbon dioxide will let the sun rays to come to the earth. So when the sun ray which comes to the earth, it is in the form of short wave. Short wave wavelength. There will be wavelength will be short wave radiation like this. When it comes and hits the surface, whatever is reflected, it is long wave. Short wave will be converted into long wave, right? Okay. So this carbon dioxide is transparent to the insolation. Means whatever the heat, that carbon dioxide will allow the heat to pass through, right? So but whatever the sun's heat which is coming into the earth, this carbon dioxide will allow, right? But once it hits the earth's surface, whatever is reflected back, it is long wave. But this long wave, the carbon dioxide doesn't allow. So it is opaque to the long waves which is reflected back from the earth. That is why the sun's heat will come and hit the earth. When it gets reflected, the carbon dioxide doesn't allow and carbon dioxide warms the earth. So that is why the global warming, because of increasing carbon dioxide. Did you understand? Okay. So it is opaque to the reflected radiation from the earth. So it absorbs the terrestrial radiation. So terrestrial radiation means what? The radiation or the energy, heat energy which is reflected by the earth's surface is terrestrial radiation, and it is absorbed by the carbon dioxide. Some of it is absorbed, some of it is left to the space, right? It is left back to the space. So carbon dioxide, because it absorbs the terrestrial radiation, it leads to greenhouse effect. Greenhouse effect. What is greenhouse? So greenhouse is one such house. So it will be, see, infrared radiation, it will allow the infrared radiation to pass through, right? So here there will be plants, right? This is actually used in the Nordic countries where there is less sunlight, right? In the polar regions. So sun rays will come in, and when it comes in, it will come in the short wave radiation. Once it gets inside, it gets reflected. The reflected rays will be long wave. Long wave doesn't get outside. It will be stuck in the greenhouse. So this is the concept of greenhouse. So the entire earth will act like a greenhouse for the reflected terrestrial radiation, right? So because of this greenhouse effect, so because of the carbon dioxide increasing, temperature of the earth is also increasing, right? Then you have the this ozone. Ozone is also a gas, right? Ozone is between 10 to 50 kilometers, right? What is the work of the ozone? It prevents the ultraviolet radiation which is harmful to living creatures, right? There will be cancers because of excessive exposure to ultraviolet radiation. Then you have water vapor. So water vapor, it decreases with the altitude. At the sea level, water vapor is high. At the higher level, water vapor is low, right? So in the wet tropics, in the equatorial regions, because of the excessive rainfall, water vapor is up to 4%. In the polar regions, cold regions, water vapor is less than 1%. So from equator up to the pole, the water vapor goes on decreasing. It goes on decreasing. So this water vapor, what does it do? It also, just like carbon dioxide, it absorbs the insolation. See, carbon dioxide doesn't absorb the insolation, it absorbs the terrestrial radiation, whereas water vapor will absorb the incoming radiation, right? So this acts like a blanket to the earth. Blanket is covered on the earth, water vapor blanket, right? Because of which what happens? The temperature of the earth will be maintained. If the water vapor is not there, entire heat will escape into the space. Earth will become what? A frigid body, right? A cold, very cold body. Then you have dust particles. So these dust particles are solid particles in the air. Solid particles. What are the dust particles? You have sea salt. Sea salt is one thing. Then you have, see, when you go in front of the sea, you will feel somewhat irritation, right? So you will feel somewhat sticky. So that is because of sea salt. The salt will be there in the air, it gets stick to your skin. So that is one thing. Then you have fine soil. Fine soil will also be moving in the air. Then you have smoke. Smoke is also particle. Soot. Soot means so when you burn down a tree, whatever remains, budi, ash, that is soot, right? Soot, ash and pollen. Pollen means pollen grains of the flower or plant. So all these are the dust particles. So these dust particles will be situated in the lower layers, at the lower levels of the atmosphere. So at the dust particles will be, you can see, find the dust particles more in the subtropical and temperate regions. See, you have equator here up to Tropic of Cancer and Tropic of Capricorn. It is called as tropical region. Above this, it is temperate region. Above here, there will be polar circle. Above it, it is polar region. So you can find the dust particles in the subtropical and temperate regions. Why? You can see it in the these regions only, because in these regions there will be dry winds. You cannot find the dry winds in the polar regions, right? So that is why there will be dust particles. So these form a hydroscopic nuclei. Dust particles forms the hydroscopic nuclei. Because of this hydroscopic nuclei, cloud will be formed. So what is hydroscopic nuclei? So upon this dust particles, water will get collected and it forms cloud and it will precipitate as rain. So these dust particles acts as hydroscopic nuclei. Then you have the structure of the atmosphere. What is the structure, right? So there are multiple layers. Troposphere, mesosphere, exosphere, all these are there. So based on what the layers are found. So it is based on density and temperature variation. Temperature and density variation, these layers are formed. So this basically based on temperature variation, we have divided it into tropo, strato, meso, thermo and exospheres, right? First is troposphere. troposphere, the average height of the troposphere is 13 kilometer. 13 kilometer. See, at the equator, it is up to 18 kilometers. Why troposphere at the equator is 18 kilometer? Because at the equator, the earth is bulged. Earth is in this shape, right? So at the equator, earth is bulged. So troposphere will be high, right? So, but at the poles, troposphere is just 8 kilometers. It is 8 kilometers. Whatever the climate and weather changes you see, it will be there in the troposphere itself, right? So heat, in this troposphere, heat is transported by the convectional current. Heat in the troposphere is transported by the convectional current. Next you have tropopause. So when the troposphere ends, where the troposphere ends, it is called as tropopause. At the equator, the tropopause temperature is minus 80 degrees Celsius. Whereas at the poles, at the polar region, here tropopause minus 80. See why tropopause? Because here temperature is constant. That is why it is called as tropopause, right? So at the equator it will be minus 80 degrees Celsius. At the poles it will be minus 45 degrees Celsius. Then you have stratosphere. So it goes up to 50 kilometer, right? In the stratosphere you have what? You have the ozone layer. Ozone layer is present in the stratosphere, right? Then you have mesosphere. See here in the stratosphere, what happens? The temperature decreases or increases. So in the troposphere, actually with height, when you go high above, what happens? The temperature decreases. In the troposphere, temperature decreases. Stratosphere, it increases. Mesosphere, it decreases. Thermosphere, it increases. Exosphere also, it increases. Right? So next is mesosphere. Mesosphere up to 80 kilometers. See, where the stratosphere ends, it is called as stratopause. Then you have mesosphere up to 80 kilometers. So in the mesosphere, temperature decreases up to minus 100 degrees Celsius. So the end of mesosphere is mesopause, right? Then you have ionosphere. So ionosphere is part of the mesosphere or thermosphere. Thermosphere is also called as ionosphere. It is from 80 to 400 kilometers, right? So why it is ionosphere? Here there will be electric charges. So positive, negative ions will be there. That is why it is called as ionospheres. Your radio waves, whatever you broadcast from the earth, they will be reflected from the ionosphere itself, right? So here temperature here also increases in the thermo or the thermosphere. Then you have exosphere. After 400 kilometers, we know very less about exosphere. So here in the exosphere, there will be extreme rarefication. Rarefication means there will be very little gases will be present. There won't be much gases. So this exosphere merges with the outer space. It merges with the outer space, right? This is the concept of the, so atmospheric layers is done. Next, we will move into the concept of solar radiation. Solar radiation, heat balance and temperature. Solar radiation, heat balance of earth, heat balance and what? Temperature and temperature. Heat balance, right? So this is, so you have, first you should know the difference between air. So moving air is called as wind. Difference between air and wind, moving air is called as wind. So whatever the energy we have on earth, it is because of sun. So energy we find on the earth is because of sun. Sun's energy is only there. So this energy, this energy is sometimes radiated back. So energy is comes into the earth and sometimes it is reflected back, radiated back, right? So this this balance has to be maintained properly. So energy which comes into the earth and what is radiated back, the balance has to be maintained properly. This balance will make sure that earth doesn't become too much cold or too much warm. Proper temperature will be maintained. So because on the earth, so is there same temperature on the surface of the earth? No, right? There are various places with various temperatures. So there are different places are heated differently. When they are heated differently, it leads to pressure changes, because when a place is heated more, pressure decreases or increases? Pressure decreases with the increase in temperature. So because of when there is a pressure difference, when one region is heated more, other region is heated less, pressure will be different. So heat will transfer from one place to another via the medium of wind, right? So first we have solar radiation. So this is about the how the radiations move in the earth, right? First you have the concept of solar radiation. Solar radiation, it is actually what? It is short wavelength radiation. Solar radiation is a short wavelength. Whatever I told you, whatever comes, it is short wavelength. So this is called as insolation. Whatever we receive from the sun is called as insolation. So insolation is the energy received from the sun. Insolation, solar energy is getting in, right? So earth is this solar radiation. With respect to solar radiation, you should know certain concepts. One is the earth is a geoid shape. So you know what is a geoid shape. So earth is in geoid shape. Because of this geoid shape, what happens? The rays fall obliquely over atmosphere. The sun rays, they don't fall directly, they fall slantly on the atmosphere. When they fall slantly on the atmosphere, what happens? So because of this slant falling, there are temperature changes. So various places receive various heat energy because of the slant fall, oblique fall of the sun's rays over the atmosphere, right? So very small part of energy will be received. We are receiving only small part of the energy. So rest of the energy is wasted into the space, right? We are intercepting very small part. So what is the part? We are receiving just 1.94 calories per square centimeter. 1.94 calories is the per minute we are receiving from the sun, right? So this varies with the distance. Means what? If the earth is revolving around the sun, right? So when it is closer, we will receive more energy. When earth is farther, we receive less energy. This farthest position, when will be the earth farthest from the sun? It is on 4th July. 4th July, earth will be farthest from the sun. This position is called as aphelion. Aphelion. Helion means sun. So farthest position is aphelion. When on 3rd January, earth is closest to the sun. This position is called as perihelion. On the perimeter, earth is on the perimeter of sun. This is perihelion. In this perihelion, the insolation will be more. The energy received is more, right? Then you have variation of insolation. So how does the insolation, the energy we are receiving from the sun, how does it vary? So it varies because of the daytime. How much, what is the length of the day? Is the length of the day higher? If the length of the day is higher, more insolation is received. It varies on that. It varies on seasons. So summer season we have more insolation. Apart from that, it varies on rotation of the earth. Insolation. So night time, because of rotation, we don't receive the sunlight, right? That is one thing. So you should know that angle of inclination of the rays when it comes to sea. This is the plane of rotation. That is, earth is moving, rotating, revolving around the sun in this plane, right? Whereas we see a 66.5 degree tilt, right? You take this axis is tilted. See, this is the axis of the earth. this axis, it tilted 66.5 degree. So because of this 66.5 degree, what happens? So see, sun rays are receiving obliquely, not in a straight line, right? So see, because of rotation of the earth, we have only this part. This part we have sun's energy, right? Because of rotation of earth, see what happens? This part is not receiving sunlight at all. See, this part is receiving continuous sunlight, the northern hemisphere, whereas see here half of the earth, or not half of the earth, this is during the daytime, this is under daytime, this is during night time. So when it rotates, when the earth rotates, what happens? This position will not receive sunlight for 6 months. So this will have sunlight for 6 months, this will be darkness for 6 months because of the tilt of the earth, right? So tilt of the earth will also influence the insolation, right? Rotation and angle of inclination of rays. See, angle of the inclination of the rays, it is inclining at the 47 degree here, 23.5 degree there. So there, that also influences the insolation. Then length of the day also influences. Then transparency of the atmosphere. How transparent is the atmosphere? That will also influence the insolation. Then configuration of the land. If the land is plain area, or it is a, whether the land is plain area or it is a mountain, that will also influence the insolation, right? So the first concept is 66.5 degree. So this will, with the plane of the orbit, this is the main reason for unequal insolation distribution, right? If it was just 0 degree, if the earth was not tilted, what happens? There would have not been polar region, and polar region wouldn't be there, because there will be the equal distribution of the sun rays, right? Because of the inclination, there is, what happens? There is the difference. Then you have angle of incidence, angle of inclination of the rays. See, here the angle, the earth rays, the sun rays are inclining or dropping on the surface at 90 degree, right? So with the latitude of the place, the angle changes. See, here it is inclining at 90 degree, here at 47 degree, here at 23 degree, right? So that will, as the latitude increases, the slanting will increase. Earth, see, here it is directly hitting the earth. So here it is getting slanted, bent, right? Higher the latitude, slanting will increase. So when it is hitting directly on the surface of the earth, the area that is hit is very small. When there is slanting, when there is the sun rays come to earth in a slant space, so more area will be covered. The rays will be incident on the more area. See, this rays will be covering this much area. More area will be covered. So energy will be distributed, right? The slant rays also, see here, this directly with the atmosphere, it is not traversing much length. See, here it goes through, see, suppose this is atmosphere, if the rays of sun is like this, so it is not traversing much length. But if the rays of sun is slant, see, which length is more? This length is more, right? Slant rays will traverse more through the atmosphere, right? So that is the concept. Greater depth slant rays will go through greater depth of the atmosphere. When it goes through the atmosphere, there will be what? So in the atmosphere, what will be there? There will be water vapor, ozone, water vapor will be there, ozone, suspended particles, all these things will be there. Because of which, what happens? There will be absorption. The sun rays will be absorbed, or there might be scattering. Scattering means what? The sun rays hits a particle and gets scattered into multiple rays. So scattering will be there, or diffusion. There might be diffusion of the sun rays as well. So these particles will scatter. So because of these particles, water vapor, ozone and suspended particles, there will be scattering. So because of scattering, you see the blue color and red color of the sky. So why is it? It is because of the scattering. So the blue rays will get scattered more during the daytime, but in the evening or the morning time, you will find the red rays will get scattered more. That is why you see the red rays, right? So this all will happen in the troposphere. All these phenomena will take place in the troposphere. So spatial distribution of the sun rays. So in the tropical areas, the sun ray insolation is 320 watt per meter square. In the tropical area, it is more, and in the polar area, the insolation is 70 watt per meter square. The insolation is less. So is the insolation more at equator? Actually, more than the equator. The insolation more than the equator is more in the tropic region, because in the tropic region there will be lot of clouds. So the insolation is less, but in the equator region there will be lot of clouds. So insolation will be less. Whereas tropic region, clouds won't be there. So the insolation is more, right? Okay. Then also insolation is more over the land than oceans. The amount of sun rays falling on the land is more than the oceans. So in the winter you have less insolation, right? This is the concept. Then you have heating and cooling of the atmosphere. How does the atmosphere get heated? So it is heated by the insolation. Atmosphere is heated by the insolation. This atmosphere transmits the long wave radiation. Whatever the long wave radiation comes from the sun, that will be directly transformed by the what? Atmosphere to the surface. So it won't cause any hindrance, right? Then when the long wave form hits the surface, so the long wave form hits the surface of the earth, it will heat it. So when the long wave form hits the surface, the surface will get heated, and along with the surface, the air above the surface will get heated because of what? There is this, with the surface, the air would be in contact. When the air is in contact with the surface, what happens? There will be conduction. So the heat will get conducted from the surface. So here there will be air, right? So heat will get conducted from the surface to the atmosphere, right? So by the process of conduction via contact, the air above the surface will get heated, right? This is confined to the lower layers of the atmosphere, right? So when the air get heated, what happens? It rises above. When the air is heated, what happens? It rises above. It rises above in the form of currents. So it moves like a current, right? In the form of current, the air will rise above from the surface, right? So first is conduction. So conduction is limited to the lower layers of the air. But the next concept is convection. Convection is transfer of heat. See, at the surface level, air is heated because of conduction from the surface to the lower level. But higher level of air will get heated up because of convection. Transfer of heat from this layer to this layer. That is convection of the heat, right? So all this happens in the troposphere. All these phenomena happens in the troposphere. So this is vertical transfer of heat. Then you have the one more concept of horizontal transfer of heat. So when the heat is transferred horizontally, it is called as advection. Horizontal transfer of heat is called as advection. So you see this advection majorly in the middle latitudes. Middle latitudes means what? So from 23 degree to 66.5 degree, in these latitudes you find this process of advection. So in the middle latitudes, diurnal variation. Diurnal variation means temperature change between day and night is because of this advection. Horizontal transfer of heat. So even in the North India, you have this wind called local wind called Lu. So this loop is because of the advection process. The horizontal transfer of heat, loop will happen, right? Then you have terrestrial radiation. So whatever I told till now is insolation. Now you have terrestrial radiation. See, when a body gets heated, so it will radiate the energy, right? So it is according to which law? Planck's law. Planck's law. So when a body gets, earth gets heated up, it becomes a radiating body. It radiates the energy. What radiation? What radiation will happen? So first long wave will come from the sun. So when the long wave comes into the atmosphere will get heated first. Afterwards, this long wave long wave is from the surface. So when the long wave transfers from the surface, right? When the earth acts like a radiating body, long wave will go from the surface and atmosphere will get heated. When the atmosphere get heated, why does it get heated? Because in the atmosphere there will be carbon dioxide. Because of this carbon dioxide will, what does it do? It will absorb the radiation, it will absorb the heat and the atmosphere will get heated up, right? So when the atmosphere get heated up, what it does? It in turn becomes a radiating body, and it will transfer the heat from the atmosphere to outer space, from surface to the atmosphere, from atmosphere to the outer space. The heat will be transferred, right? The radiation will take place and heat will transfer. So this is why, because of this radiation, we find the surface, at the surface level and the atmosphere level, there will be constant temperature, or else what happens? Earth should have become heated up like anything. If all the energy was captured by the earth could have become like a hot oven. Because of this radiation, what happens? The energy is being transferred from the surface to the atmosphere to the outer space. Clear? Okay. This is the concept. Then you have the concept of heat budget of the earth. What is the heat budget? So just like a budget, the amount of heat that is received, amount of heat that is given back by the earth. So in the earth we have whatever the heat is received, that is lost by the earth, though the earth has a constant temperature. It has a constant temperature. So insolation. So whatever the insolation, this is the heat budget. So this diagram is not important. So he has just shown, if 100% comes, first there will be, cloud will radiate some radiation. The energy, some will be, heat will be radiated by the clouds. Then some 34% is absorbed by the earth. Some 14% is absorbed by the atmosphere. Then some 17% will be radiated by earth directly into space, and from 48% will be radiated back by the atmosphere, from the atmosphere to the space, right? So what is the heat budget of the earth? So first, whenever the sun's energy comes into the earth, it is either reflected. So see, it is either reflected. So 35% is directly reflected from the atmosphere. Rest or it is scattered, or it is absorbed by the earth. 65% is absorbed by the earth. Who absorbs it? It is either the surface will absorb it, or it is the atmosphere which absorbs it. So atmosphere absorbs 14%. Earth will absorb 50%, surface will absorb 51%. So this surface will absorb 51% in total. So whatever here the reflection is taking place now, direct reflection, that is called as albedo of the earth. Earth reflecting the sun ray directly is called as albedo of the earth, right? So this 51% is also reflected back. So here see, this radiation from the earth, from space 17% and 65%. 65, 48. 48 plus 17 is how much? 65. So whatever the 65 is received, it is given back. So there is zero balance, right? Zero balance of the earth. This is the heat budget. So variation in the net heat budget at the surface. So at the surface you have certain variations. See, all surface across the earth won't receive the same heat radiation. Some will receive more, others will receive less, right? So some places you have surplus. So what is the surplus? Up to 40 degree. From equator up to 40 degree, you have surplus radiation on both the hemispheres, north and southern hemisphere. See, polar region, you have deficit radiation. Surplus radiation means what? Above average radiation is received. In the polar region, below average radiation is received. Clear? Okay. So this what happens? See, from the surface surplus region, see, if more radiation is received within 40 degree north and 40 degree south, what happens? This place should have got eaten up properly. It should be eaten more than any other place. And these places from 40 to above, 40 and above should have got frozen. But there is a transfer of heat from the surplus to deficit region. So there is a redistribution, right? This is the concept of the net heat budget at the surface. Then you have the concept of temperature. So what is a temperature? Temperature is the measurement of heat. So what is heat? So heat only, if you apply heat to a body, there will be molecular movement, molecules. So if you apply more heat, the molecules will vibrate more, right? If you don't apply, so when you apply heat, the molecules will be vibrating. How do you measure the heat? Via the temperature. So what are the factors for distribution of heat? How does the heat get distributed? It is based on, first is latitude. Latitude is the factor. See, if this is earth, tropical regions receive more temperature, more heat. So the temperature will be more. Insolation is more at the tropical region. As we move towards the pole, the heat will get reduced. So latitude is the first thing. Then you have altitude. Altitude means what? Height, right? So you have in the altitude, you have at the mean sea level, there is high temperature. At the sea level, we have the highest temperature. As we go up, temperature reduces, right? So this, why does the temperature increases at the bottom? Because of the terrestrial radiation. Atmosphere captures the terrestrial radiation, because of which the heat will be more, right? But at the sea level, and the temperature is going to reduce as we move up. This is called as normal lapse rate. The temperature reducing with the height is called as normal lapse rate. So it is called, the definition is rate of decrease of temperature. How much temperature decreases with the height. So it is actually how much? 6.5 degree per kilometer. The temperature decreases. If you move 1 kilometer above, the temperature reduces by 6.5 degree Celsius, right? So then you have sea distribution. So the third factor is, third factor affecting the temperature is how far is the place from the sea. So at the sea, what happens? You must know this factor that land gets heated up fast, loses heat fast. Whereas sea gets heated slow, also loses heat very slowly, right? So at the sea level, when there is a, in the oceans, the heat variation is less because it gets heated slowly, loses heat, heated slowly, loses the heat slowly, right? There is less variation. So if a place is close to the sea, what happens? There is moderation effect. What is moderation effect? See, when the land gets heated up more, sea will be less heat. What happens? The air will move from, when the heat is more, what happens? Pressure will be less. So air will move from sea to land. when during the night time, here there will be cold. Land will be cold, sea will be hot, right? So what happens? Air will move from cold region to hot region. So there is moderation effect. Temperature neither increases more or decreases less, right? There is proper. Whereas when you see places like Delhi, so there is extreme temperature because there is no moderation effect of sea. So this is called as land breeze. Land breeze, this is called as sea breeze. Sea breeze. Clear? Okay. Then you have air mass. So air mass circulation, that will also affect the temperature. What is air mass? So if the air is hot, the temperature will be hot. If the air is cold, the temperature will be cold. Also currents, ocean currents. I told you what is a current. If the ocean current is cold, the temperature will be cold around that region. If the ocean current is hot, the temperature will be hot. Next you have the distance, distribution of temperature, distribution of the temperature. So January and July, what is the distribution of temperature? See, in the first you should know the concept of isotherm. What is a isotherm? Isotherm is a line joining places of equal temperature. Isotherm is a line. See, all these are isotherms. So these are lines which join the places of same temperature. See, this isotherm is 20 degrees Celsius. See, wherever this line goes, there will be 20 degrees only. So it is a distribution or the line joining the areas of similar temperature, right? So these isotherms are parallel to latitude. See, they are parallel, right? They are always parallel. So January variation in the northern hemisphere. So in the northern hemisphere, why does the isotherm bend like this? They should be parallel to the latitude. Why do they bend like this? So why do they bend? Andre, in the northern hemisphere, land is more. So this is in the month of January. In the month of January, what happens? Northern hemisphere, it is winter. When there is winter, land will be more cold and ocean will be still warmer because it would have not lost the heat from the summer. So what happens? You take this 0 degree isotherm, or you take 10 degree isotherm. Better you take this 0 degree isotherm early. See, here it is moving up. Here also it is moving up, but it is coming down here. Why? Because 0 degree, this way 0 degree will move up to here. Means this place is hotter, whereas illi 0 degree there, right? Whereas when it comes to 0 degree in the ocean, it is above. Means at this level, it is how much? 10 degree. So at the same level, see, if you take the same level on the land, it is 0 degree. On the ocean, it is 10 degree. Means what? Ocean is warmer in the month of January. So since this is a line connecting places of equal temperature, illi 0 degree there. Where do you find 0 degree in the ocean? You will find much above towards the poles. So here, so on the same, if you take the same latitude, see 10 degree, it is 10 degree here, 0 degree here, right? So illi land cold ide. Land is colder. That is why just above the equator you are finding 0 degree. But ocean is warmer. So 0 degree find madbekandre, you should go much upper, right? This is the distribution of temperature in the January, right? You see there is this concept of thermal equator. Equator andre, thermal equator means normal equator bere, thermally, according to the temperature. What is the equator? This is the thermal equator, right? So that is where the sun rays falling properly. So this is the thermal equator in the month of January. Andre sun rays are falling exactly here, not on the actual equator, right? Falling vertically on this equator, thermal equator. See, in the January, illi southern hemisphere, it will be what? It will be summer, right? Summer, land will be hotter. Land will be hotter and sea will be colder from the past winter. So what happens? Take the 20 degrees Celsius isotherm. So 20 degree, if you have to find land on the ocean, you will find it very close. Just ishtu dura bandre, you will get the 20 degree. But to find the 20 degree, since land is hotter, you have to, or since land is hotter, 20 degree bekandre, you have to move till here. Because see, at the same level, you have 20 degree on the ocean, land ali 30 degree there. So land is hotter in the summer. So this is the concept, right? Why andre illenike ee tara variation agate andre, because land area is more in the northern hemisphere, land area is less in the southern hemisphere, right? So here see, isotherms are deviating towards the north. It is moving towards the north over oceans. They are moving towards the north and they are deviating towards south in the continent. So this is the concept of isotherm. Then you have Atlantic. See, why does the ocean is warmer? And there is one more reason. Here ocean currents are warm in the Atlantic Ocean. Ocean current. Also there will be, see, this is Gulf of Mexico. Illinda ಒಂದು current ಹೋಗುತ್ತೆ, that is warm current. ಆಮೇಲೆ ಇಲ್ಲಿ North Atlantic drift ಅಂತ ಇರುತ್ತೆ, that is also warmer. Because of all these reasons, the Atlantic region will be warmer. Atlantic region will be warmer. See, this illi this is with respect to the northern hemisphere. Here the temperature difference, this is actually more in the Siberian region. Temperature change will be more in the Siberian region, this region. Then you have ocean in the southern hemisphere. In the southern hemisphere, what happens? Ocean effect. Because of the effect of the ocean, the temperature will be different in the southern hemisphere. See here, these latitudes are, see, illi there is changes. There is lot of variation. Here it is moving towards the north, on the land it is moving towards the south, whereas in the southern hemisphere, the isotherms are parallel to the latitude, because there is only ocean here, land area is very less, right? Clear? Okay. Then you have, we will move towards what will happen in the month of July. See, in the month of July, here it is parallel. Now, because July, what happens? It is summer in the northern hemisphere. Land will be hotter, this sea will be colder. So, in order to find 10 degree, see, you take the same level, see, here only you will find 20 degree. It is colder. See, at the same level you have 30 degree. Land is hotter. On the other hand, you see here, here there will be winter in July in the southern hemisphere. So, there is variation. Here you find 20 degree here, 20 degree. So, land is, this ocean is warmer, land is colder in the southern hemisphere, right? So, that is why you find these kind of isotherms in the southern hemisphere. So, in the month of July, this is the variation, right? So, the range of temperature, where does the maximum temperature variation take place? So, it takes place over the land in this region. In the Siberian region, you find the maximum temperature variation. And between summer and winter, the maximum temperature variation happens in the Siberian region. Why? Because there is no oceans. When the ocean is there, there will be moderation of temperature. Here, since there is no ocean, this is called as continentality. Because of continentality, the temperature change is very less, right? So then you have the concept of inversion of temperature. What is inversion of temperature? See, normal lapse rate. According to normal lapse rate, what happens? With the increase in height, the temperature should decrease. Alva. With increasing height, the temperature should decrease. Whereas, with increasing height, if the temperature increases, that is called as temperature inversion. So, this temperature inversion, if it happens, it will happen only for a short duration. What are the reasons for temperature inversion? See, heat is radiated from the earth, right? So, when the heat gets radiated from the earth, See, generally what should happen? Here it should be hotter, above it should be colder. So what happens in the, you take this condition of long winter night. When there is a long winter night and skies, in the skies there are no clouds. The sky is clear. When the skies are clear, what happens? And the air is still, whatever the heat of the surface is there, that will get radiated off in the night time. That will go into the space. So what happens? The land will become colder and atmosphere will be still be warmer, right? That is why you find colder space here, hotter space here. So there will be variation of temperature or inversion of temperature, right? This is only for a short duration. Okay, so this temperature variation is normal in the polar places. In the polar regions, you normally find the temperature inversion, right? So this, because of this temperature inversion, it promotes stability in the lower atmosphere. Lower atmosphere ಅಲ್ಲಿ stability ಆಗುತ್ತೆ. So where you find these fogs, right? Fog at the lower level on the mountains. So it is because of temperature variation. Above the fog, the temperature will be high, but lower level, the temperature will be low. So that is why the fog will be formed. Next, you have hills area drainage. So in one more condition, the temperature will, variation will take place. So let's say this is a hill. So what happens? So here cold air will be there because with the at the hill station the air will be cold, because with height the temperature decreases. What happens during the night time? During the night time, the cold air will, suppose let's say the cold air will flow down the valley, because of cold air is, weight is high. When the weight is high, it is going to flow down the valley because of gravitation. Because of gravitation, it flows down. When it flows down, here this is heavy, this cold air is heavy and dense, it flows down and gets accumulated at the bottom of the valley. When it gets accumulated at the bottom of valley, here there will be cold air, above there will be warm air. Here also temperature variation, inversion takes place. This is called as cold air coming down the valley is called as the phenomena of air drainage. Air drainage, right? Next, briefly we will discuss the concept of atmospheric circulation and weather systems. Atmospheric circulation and weather systems. So what is atmospheric circulation? So when the air gets heated, what happens? It expands. Atmospheric, the chapter is on atmospheric circulation and weather systems. So what is the circulation in the atmosphere? Air circulation. Okay. So when the air gets heated, what happens? It expands, right? When it gets cooled, it compresses. Air will get compressed when it gets cool. So this phenomena you should know. When the air gets expand, because of it, what happens? Pressure will increase or decrease. So when the air gets expanded because of increasing temperature, pressure will decrease. Pressure will decrease. So when the pressure is decreasing, so someplace there is a increased heat. Because of heat, the temperature will rise. The temperature rise, the pressure will decrease. Air will expand. When the air expands, the pressure will decrease. On the other hand, there is a cold area. Cold area, the pressure is high. Air is not heated up, it is compressed. Pressure is high. So air flows from which area to which area? From high pressure to low pressure area. This you should know. So also vertically, see, suppose at the lower level the pressure is low and the higher level the pressure is high, the air will sink, right? Suppose at the lower level the pressure is high, upper level pressure is low, air will rise up, right? Air will rise up. So air is going to sink as well as rise. So when you take the example of moist air, air which is moist, so that air, what happens? When it rises, when the moist air rises, it cools. Moist air, it will be hot. See, when the air in the atmosphere is hot, it is going to evaporate the water, convert it into water vapor. So this will rise up. When it rises up, what happens? It will cool. It will cool. When it cools, it gets compressed, and compressed, because of which there will be rain, right? Rain will take place. Then you have this concept of atmospheric pressure. What is atmospheric pressure? So atmospheric pressure andre, it is a weight of column of air over unit area. See, from the top entire troposphere alli, what is the weight of air at the mean sea level? So the weight of the column, this entire column of air at the over a unit area, entire column of air unit area mele ಎಷ್ಟು weight ಆಗ್ತಾ ಇದೆ, that is pressure. So pressure is measured in which unit? It is measured in millibar. Pressure is measured in the millibar. At the sea level, the pressure is how much? 1013.2 millibar. 1013.2 millibar, right? So gravity, see what happens, the surface air, at the surface the pressure will be very high. At the surface the pressure will be very high. Surface air at the surface will be very dense. Proper surface idre alli air will be dense. Because of dense air, there is high pressure at the surface. So when there is high pressure, what happens? So why there is a high pressure at the surface andre? Because of the air column falling on the surface. Also there is a reason of gravity. Gravity is also pulling the air, because of which there will be high pressure. So what instrument measures the pressure? Barometer measures the pressure, right? So pressure also, just like temperature, it decreases with height. As you move up, the pressure is going to decrease. So what is the vertical variation of pressure, right? So when we move upper, the pressure is going to decrease. As we move up, the pressure is going to decrease. What is the fall? Actually, for every 10 meter increase, if we move 10 meter from below to above, there is 1 millibar decrease of pressure. 1 millibar for every 10 meters. But unlike temperature, it is not going to decrease similarly. The decrease of pressure with height varies from one position to one place to other place, right? This concept you should know. So then you have pressure gradient force. This force is very, very important. What is pressure gradient force? This is a vertical force. Pressure gradient force is a vertical force. So what is vertical force? So this vertical, see what is the pressure here and here. The difference between two pressure is called as pressure gradient force, right? So this vertical pressure gradient force is larger than the horizontal pressure gradient force, right? Vertical pressure gradient force is high. See, when there is so this pressure gradient force here, pressure is higher, here pressure is lower. So all the air should move upright from lower pressure to higher pressure to lower pressure. If that is the case, all the air on the earth should disappear into space, alva. But why doesn't it happen? Andre, there is an opposite force called gravity. Gravity will pull in the opposite direction. That is why pressure gradient force is on the opposite side. It is balanced by the gravity. You should know this concept, right? Okay, then there is a last concept of the day is horizontal distribution of pressure. Horizontal distribution of the pressure. So wind. So I told you if there are two places on earth, so what determines the direction of the wind and velocity of the wind? So both of these things are determined by the pressure. If there is high pressure variation, so the direction the air moves from high pressure area to low pressure area, direction is determined. What is the force it is going to move? If the difference is more, velocity is more. So both of these things are determined by the pressure. So just like isotherm, the lines of equal pressure are called as, the line which goes through equal pressure is called as isobar. Isobar. So this isobar, I told you, pressure, it varies with what? It varies with altitude. It varies with the height. So the isobar. So the pressure is always measured at in the isobars, it is measured with respect to sea level. Always the pressure is measured by reducing the height to the sea level, because with the height the pressure varies. So we should always reduce it to the sea level to measure the isotherm, right? So the last thing is a low and high pressure system. What is a low pressure system? So at the center, if there is air like this, if there is a air system like this, at the center, if there is low pressure, this is called as low pressure system. At the center, if there is high pressure, it is called as high pressure system, right? So tomorrow we will discuss the word distribution of pressure. How does the pressure is distributed across the world, right? So if you have any doubts, please contact us on the Virat Hindustan Sangam Telegram group. Also, please give us the feedback about the classes. Any suggestions, any improvements you want, you can always contact us, right? So please take good care of your health. Please make good use of the classes and we will meet tomorrow. Jai Hind, Namaste.